Welcome, everyone. Welcome to the ITS Davis seminar. And this is our first event of the new year. And we have a very special guest that's going to be addressing us, Myers Jaffe. And so I'm Dan Sperling. I'm a professor in civil engineering and environmental science and policy at UC Davis, and I'm director of the Institute of Transportation Studies. So I welcome you all, and I see that there's a huge number of you. That's fabulous. So the Myers Jaffe. I have a long history with Myers, and even a long history before me. So Myers studied, so I'm going to give you her life story a little bit because it's kind of to show you that there's a lot of paths forward. And I think that's the message, especially those of us working in the energy area, environmental area, transportation area. There's no set pathway. There's lots of different kinds of jobs and a lot of different kinds of situations. And I think Amy's career path illustrates that well. She started out, she got a degree in Princeton on the Middle Eastern studies and learned Arabic. She was a journalist after that. And then after that, she was headed up the energy research program at Rice University in Texas. And then we lured her here to Davis. And in Davis, she played a very important role in building up many of our energy programs. And actually, one of the special benefits I gained out of it is that Amy brought her journalistic instincts and taught me how to write op-eds and blogs. So I'm very grateful to Amy for that. And then she moved on. She went to the Council of Foreign Relations in New York City and worked on energy policy, international energy policy there, and transportation. And now she's at Tufts University. And so Amy, really, she's one of the best known people in the world dealing with international energy policy, especially related to the energy industry and the Middle East. And she's, the time she spent with us in Davis, she really brought a lot of that expertise to transportation, and so, which we've really benefited from. And so now she's going to talk about bringing together the transportation world and the energy world. And I think you're going to find her fascinating. So Amy, thank you so much for joining us. We really appreciate you taking the time and effort, and we especially appreciate the time you spent in Davis with us for, what was it, about 4 or 5 years, I think. So thank you very much, and take it away.
Excellent. Well, it's really a pleasure. I wish I could say to be fully back, like actually be in West Village. But it's great to see some old friends and visit now with some new friends. And let me just say, for the students who are saying, how did she go from Arabic to ITS? Let me just say, I worked on trucks at ITS and sustainable freight. So really like a far pivot. And what I would tell you is, I laugh with the people now. I say my career is almost like a historiography of the energy business, that I started out first writing about oil geopolitics and the Persian Gulf. And then I had a pivot to the politics and geopolitics of natural gas. And then I had a pivot to writing about electrification and sustainability and transportation, alternative fuels. And then even that wasn't enough. And so then I pivoted to look at tech and what's coming from the tech industry that's either going to make the problem better or make the problem worse. I have a book coming out called Energy's Digital Future. And now I'm completely pivoted because I'm the managing director of a climate change center at Tufts. So just to show you how my priorities and society's priorities have moved from worrying about our oil supply getting cut off from the Middle East to 100% concern about climate change. So I think that my career reflects how American society has changed over the years. And congratulations to Professor Sperling, who was more ahead of the pack and pivoted faster than the rest of us. So all good. So I want to talk to you today a little bit about what COVID-19 has meant for both energy and transportation, specifically thinking about the energy transition. Next slide. And to do that, we're going to have a 2-minute energy economics lesson. So there are two terms that you hear when we talk about energy transition and think about how technology is going to interplay into our future economy. You know, you hear about green development or green stimulus, green industrialization. You know, what are we talking about? So a lot of times people get confused between the term energy intensity and the term energy efficiency, and they do not mean the same thing. So the energy intensity of an economy is related to the amount of energy it takes to generate 1 unit of gross domestic product. So, and a country's energy intensity can vary from the energy efficiency of its appliances and durable goods, because it can have to do with how large a percentage of the population is in agriculture or in heavy industry, and it can have to do with how well industry is in terms of productivity per worker, or using automation to get increased productivity. Can involve land use, which I know is something that many of you study from the transportation perspective, and so forth. So all of those things influence a country's energy intensity, and also the percentage of people who work in the service sector. A lot of times in an advanced economy like the United States or Germany or England, you have a high percentage of people working in the service sector, and that lowers the energy intensity of the country, because with the exception of the cloud, which we'll talk about, you know, generally speaking, banking is a less, you know, intensive energy activity than manufacturing steel, for example. Now, how does energy efficiency, and I'll go back one more time, how does energy efficiency intersect? Well, energy efficiency means use less energy to perform the same task. In the case of our machinery, especially for vehicles, energy efficiency means that if our vehicles are more efficient, of course, that's going to lower our energy intensity. Okay, next slide. So how I put that into the context, let's talk about two big economies that we all study from a transportation sector side, because their policies are so influential to global trends. And let's take the oil intensity measure. So moving away from energy per unit of GDP and talking about how much oil I have to use per unit of GDP. So the United States oil intensity is now 92% less than it was before the 1973 oil crisis. And part of that is having to do with, you know, standard efficiency standards for vehicles. A lot of that has to do with the fact that oil is no longer used in electricity generation. And also some of that has to do with how many miles driven we take, and what kind of form of energy is going to be used for those miles. China used to be very energy inefficient economy. They have been trying to proactively reduce the energy intensity of their economy because they became a net oil importer, and they're rapidly, their imports are going to be, they are already much higher than the United States, but they about 10 or 11 million barrels a day, moving towards 13 as a projection. But they have both shifted from rural agriculture to urban living, and they also have a strong government policy on energy efficiency in vehicles, industry, and buildings. And as a result of that, the China's economy is 26% less oil intensive than it was in 2000. So next slide. So generally speaking, and this slide kind of shows you the energy intensity of the world economy is starting to go down, but there's differences between those countries in the OECD, like the United States and the EU, where actually we're getting less and less oil intensive and energy intensive, and the developing world, especially Latin America, Southeast Asia, and Africa, where we're still on an uptick in terms of the energy intensity of expanding economies. Next slide. And in oil intensity, we're seeing a distinct flattening in the oil intensity of the OECD, so that's the Western industrialized countries. And there are predictions that China is also soon to flatten out. And I think the question for both energy security students, transportation students, and those who care about climate change is how do we flatten the whole global oil intensity? Next slide. So what happened during COVID was very unusual because we had the lockdowns and literally people stopped using oil overnight because we stopped using jet fuel and international transportation came to international travel came to a halt. Trade was restricted, so we used less oil and marine fuel. People were driving less originally at the beginning of the pandemic. And that actually created this crisis where there was so little oil demand, as you can see from this table and comparing it to the financial crisis when recession curbed oil demand. There was so little oil demand in the second quarter that a crisis ensued where oil had to be put in storage because, unlike milk, which we saw dumped out on the ground in Wisconsin, you can't dump oil anywhere. It's toxic material. So people were hiring ships and looking for storage tanks, anything to find a place to put the oil that was being produced because you can't, because of technical reasons, because it'll destroy the pressurization of fields. With many reservoirs, you can't just turn it off. You have to keep a certain level of production. And that created a crisis in the market where where we almost ran out of storage space. And that led to a sort of historic agreement between the United States and OPEC and many other oil producing countries to try to stabilize the oil market and prevent this crisis from happening where oil piled up in inventory. But next slide. That crisis, which seemed to finally at this point, I guess, is dissipating, though, we still have some volatility in oil prices, whether you think the vaccine's going to work, that caused oil prices to go up. Then all of a sudden, it looked like we were back in lockdown, that caused oil prices to go down. But it focused people on two things. Number one, what is the viability economically of companies that are oil companies, because of course their stock went down on the New York Stock Exchange and their future looked cloudier. But secondarily, now you have a lot of stimulus, economic stimulus coming from Europe and from South Korea and Japan and now the United States. And the question is, what will be prioritized? So with the new Biden team coming in, there's the symbolic slogan, how you want to characterize that, building back better. And you're going to see people who are going to become the science advisors to Joe Biden on the energy technology side are going to be focused on deploying RD&D, research and development funds, on new next generation technology, and what are the kinds of technologies people are going to look at. They're going to look at AI, they're going to look at the industrial internet, as it's already been sort of mentioned in the press. The Biden team is very focused on how to get EV charging off the ground. We already have momentum on electricity storage, which is sort of complementary to building renewables and renewables that are integrated with EV charging. And can your EV be the storage? So one of the interesting puzzles on the storage side is going to be whether we have support for hydrogen or hydrogen electrolyzers. But when you put it all together, the question is going to be, what happens with all this sort of digitization? And what do I mean by digitization? By that, I mean the kinds of things that you're studying at ITS. So using automation in vehicles, will ride sharing go to robo-taxis, and will they be green vehicles? Will we have policies that regulate the tailpipe emissions for ride sharing fleets? How we use big data, in transportation logistics on the freight side, regulating and encouraging these artificial intelligence big data programs that bring you your packages efficiently instead of you driving inefficiently to the store. Some of that is increasing energy use right now, but in the end, done and programmed efficiently, in the first few years, it actually reduced vehicle miles traveled. So how do you get e-commerce to focus on, again, clean trucks and in a more efficient system of distribution and last mile transportation in a way that, again, lowers emissions from freight? And then I focused a little bit on 3D printing, and that is because if I'm manufacturing goods in one place, and my slide here is a picture of a Denali jet engine. That jet engine used to have 895 parts. They were made all around the world. When they got shipped in boats that used marine fuel, so transportation issue. And if I can now, Cessna that makes this engine is going to 3D print it, it's going to have 8 parts. I will not be transporting the 895 components. And so therefore, presumably that's going to, even though 3D printing itself uses more electricity, that electricity can be renewable. And but the oil we eliminate in marine transportation will be substantial, and that can be a climate policy. So next slide. So one of the things we've seen with COVID, and let me bring it back to COVID, is that COVID has accelerated some of the technologies that were coming anyway that could be used to lower emissions and could be organized in a way to bring us on an energy transition that has could favor renewables, favor battery storage, favor some of EVs. And what am I talking about? So when we had the crisis for PPE to help our medical professionals, companies that had 3D printers for their businesses, and say, for example, in the city of Houston, the drilling industry uses 3D printing. They suspended all of the 3D printing for drilling and used it all to do masks and other kinds of equipment that was needed by the hospital system in Texas. So we have more mainstream use of 3D printing. At the same time, we're doing this meeting. Normally I would have flown to California and had a barbecue with all of you tonight, but I'm doing it by video. So we're doing a lot more by telecommuting, and that eliminates transportation energy use and makes us a less oil intensive economy. And then, as I mentioned, e-commerce has a lot of potential to reduce the oil intensity of the US economy. And we're seeing that in China, where buses and trucks have been moved away from oil. So what I'm going to show you now is a modeling exercise that we undertook together, my colleagues here at ITS, and I also, besides working at Tufts, I have a position at Columbia, and which focuses, one aspect of it focuses on promoting women in the energy space. We women do a great job on sustainability, so shout out to women in energy. But I also work on the subject of peak oil demand and forecasting the possible peak of oil demand together with the Columbia team and the ITS team. And so I'm going to show you a preliminary scenario. The final studies, new runs are being made. We are improving our scenarios, but this was the original scenario. There were 4 scenarios, but I'm picking my scenario that's my post-COVID high-tech digitization scenario. And so in my scenario, which is sort of a peak oil demand scenario, the fact that we have successive waves of pandemic and we fear that maybe COVID is not going to be the last pandemic, that you see this emergence, which we're seeing among major economies like the EU, like China, like the United States, to focus on high tech as a economic recovery, as a technology innovation, as a way to create future jobs and a more competitive future workforce. If you think about all these hacks we read about in the news, we're going to need an entire workforce that focuses on cyber and cybersecurity. If you think about the fact that we're going to move to automated vehicles, which I think is pretty much a given, that's going to go with 5G. We don't want it to be that not only can some hostile player turn off an electricity system in a part of the United States, we also don't want them to be able to knock down all the systems that support automated vehicles. We don't want to have to worry that we're getting in our automated vehicle in a major city and there's a cyber hack and there's major car accidents related to the operation of those vehicles. So cyber is going to be big. We're also going to see innovation in biotech and other strategic industries that will lend itself to again, to green technologies and transportation. And then in this world that we're talking about in this scenario, we assume that countries want to have their own tech manufactured in their own countries, and that they're going to take the steps it takes to do that, and that is going to shorten trading distance and reduce global trade, the result of which again will be a peaking in marine fuel from the shipping industry, and also less international travel by plane. And we figure that's going to lead to lower oil prices, which might mean that you could have some kind of a 1973 oil crisis at some point, only because oil producing countries are going to have such economic hardship that could lead to instability. So next slide. As we run those scenarios and craft them into outputs, what we find is a drop in passenger vehicle mile travel. Some of it also is offset to the extent that we maintain the current pattern where people are afraid to use mass transit, or you have a reduction of, with ride sharing. Maybe it's more I'm calling you from my house and less that you're just driving around a city and looking for passengers. As I mentioned about global trade, and then we also have cost declines because we're having all these government programs to support EVs and the technology around EVs and hydrogen and biofuels. We see this sort of faster pace of transition in the transportation sector to things like EVs and electric trucks and even different fuels going into the heavy duty sector. So next slide. So what does that all look like when we throw it into the hopper we use some facsimile of the transportation model of the International Energy Agency. And I'm happy to show you, because I think this is a likely scenario that could possibly happen. If I had a pointer, I don't know if my pointer actually works on the screen because Natalie has my slides, but this bottom blue line is the forced revitalization line. And if you want to compare it to forecasts you might know about, BP's net zero scenario is the green squares. So you can see in the 2025 period, forced revitalization is even more oil reducing than BP's net zero scenario. But over time, that BP's net zero scenario does eliminate more oil use. And comparing it to IEA their sustainability scenario would be the gray triangle. So you see that this forced revitalization scenario, this digitization of high tech into the transportation sector would have a huge impact, bigger impact than the kinds of things that are predicted by the International Energy Agency under its sustainable policies, business as usual, and even below their 2 degrees and 1.5 degree scenarios. Next slide. So what has that meant? You know, out there in the real world, people have to make decisions about how to invest. So if you're a giant pension fund, you know, during my time at Davis, I got seconded to the UC pension fund for a period of time, and we had to make decisions. I know some of you are students at the UC. We had to make decisions about divestment. Do we divest from all oil companies? Do we divest from certain kinds of companies? You know, how do we decide how to invest? And as this revitalization scenario in these technologies and the COVID impact and everything comes together, and we see more momentum with Biden being elected, and we're imagining a more of a global agreement to reduce emissions, you can see that investors have responded to that by thinking, I don't want to own ExxonMobil stock anymore. And you see that in 2020, Exxon's stock price fell from $73 a share to under $32 a share. It's rebounded a little bit in the last couple of weeks, but I think once the market realizes we're going back into lockdown, they'll be back down again. And then you can see that, of course, Tesla has made an unbelievable recovery. And if you look at the vertical axis on the all the way to the right, that is market cap. And you can see now that Tesla has a higher market cap than Exxon. And part of that is, you know, the impact of COVID currently, but a lot of that is anticipatory. In other words, people are imagining that Tesla has a huge growth potential as a company, and that Exxon does no longer has a growth potential to company. They're going to be a company that's going to shrink and underperform over time, going to have stranded assets. And you can see that the market is reflecting that in their anticipation, and it becomes self-fulfilling because as ExxonMobil's market cap falls, they have less finance to invest in oil assets. And so it has an effect of shrinking their company and shrinking the oil industry. At the same time, it's giving a very expansive effect to Tesla. And the other thing that people are betting on when they buy Tesla stock and short Exxon stock is that Tesla is going to continue to develop technologies that are going to have broad applications, right? So not only does Tesla have batteries that can be used in the car, but their batteries are used for storage systems with solar and wind, but also in their cars, they have a HEPA filter that has, you know, bioterrorism and pandemic properties that are positive. And someday maybe they could spin those off to a building system or to some other kind of transportation, say they design them for airplanes. So that's another reason why you would want to favor a Tesla stock. And the question really is, you know, what this picture tells you is that the market does not believe in carbon sequestration, because then maybe you would feel that Exxon would eventually figure out a way to sequester the carbon. But the market does not have confidence in that. Okay, let's go to the next slide. And this slide shows you again using a different kind of metric. So how many times higher than cash flow? So what we call that the multiple. How many times capital? So when you look at the stock of a company, how many times its cash flow is the price per share? And if you look at these renewable energy companies like Solaria, you know, we're talking about over 50 times the cash. So its shares are over 50 times more than its cash flow. Whereas a company like Total or Shell or Equinor, which are oil companies that are pivoting and doing some renewables, their multiple is only 4 or 5 points above the cash flow. So that shows you that the market really favors pure play renewable companies. Next slide. So last comment before we get to our discussion and questions and answers. I've worked together with Lou Fulton to look at how would the oil intensity of the economy be affected by a massive implementation of bans on the sale of gasoline and diesel vehicles. And we started with cars, passenger cars. And you can see in these scenarios, when you go out to 2040 and 2045, it does, even that one policy alone could actually create a peaking in oil demand, but, and there's a big but, it's a blunt instrument. And what do I mean by that? Because it addresses new vehicles and not the vehicles that are already on the road. Most people in the United States keep a car for over a decade. And so it's it sounds like a really, really extreme policy, but actually it's not, because most people keep their car for a long time. And then after they use that car for a long time, they bring it to CarMax and somebody else uses that car for another 5 years. So, and then that's true in other countries as well. So, you know, a little shorter in Germany, 6 years, China, 6 or 7 years for a vehicle. So even banning ICE engine cars, it's still a low process to remove the oil intensity of the transportation sector. And so we believe that that kind of policy needs to be coupled with other policies that would help move things along faster. Okay.
So, Amy, thank you so much. Lots of provocative ideas in there. Just a very simple one. Some people need to know what OECD is. Can you just say what that is?
That is the organization, of economies in the economies.
I think it's Organization of Economic and Community Development, I think.
Yeah, not community. There's some other
cooperative.
Right, cooperative. So that is it is a entity that defines basically the industrial countries. So United States, Canada, South Korea, Japan, Australia, and the European countries. And they are also the members of the International Energy Agency.
Okay, so here's an interesting one. What do you think is the effect of ZEV regulations, essentially zero emission vehicle regulations on Tesla stock values? I guess that's both past and future.
So here is my view. The ZEV mandate was instrumental in introducing policies to support it, like you can park for free in the airport or you can use a carpool lane, and other kinds of incentives, the subsidies and so forth, that help Tesla get a little bit off the ground. But I think the two things that made the biggest difference for Tesla It's just an opinion, something that somebody should study in a case study. One was getting the stimulus funds in 2008, 2009. They got a loan guarantee to open, to fund and open the Fremont factory, and that helped them. But honestly, the stock didn't really take off until they got their new manufacturing plant in Shanghai. And the market believed accurately that Tesla was going to have a giant market share in China. And that's such a big and important market that whatever pessimism people might have had about whether Elon Musk was tweeting crazily or whether or not Elon Musk could get Americans that weren't wealthy to buy his car, that once people saw that he was going to do this and he was doing it in China and he was successful in China, that actually is, I think, contributed greatly to the company's current success. And I would tell you that I know you probably have a lot of international students, but also some American students. That's why in this, sort of scenario that I showed you about whether countries are going to be competitive. So, of course, Tesla's an American brand. And the question is, will the United States continue to provide jobs in a competitive landscape for companies like Tesla to develop? Or the fact that companies are not having the right regulatory framework in the United States to help them along outside of California, will they go to places like China or Europe? And will China and Europe have more successful automobile industries than the United States because we don't have the sort of regulatory framework that supports advanced vehicles? And that is a really critical question. I think you're going to see much more when we get past this topic in a transition of power in the United States. I think 6 months from now or 3 months from now, you're going to see an intensive debate in the United States on transportation and on technology about what the United States should be doing. And the previous administration's approach, which was to ban certain technology transfer to China or other countries and to put tariffs on or block technologies from those countries coming to the United States or even human beings coming, that's going to be put aside as unsuccessful. And the question is, and I see the sort of slogan of it, is the United States going to position itself not to block some other country, but to win by doing, right? By having, better researchers, better companies, better incentives. And that could help a California with some of its regulations, even if there's still industry that's tempted to think it wants to sue the state for its policies. You're going to have the momentum that you're going to have a lot of people on both sides of the aisle in Washington looking at stimulus and saying, we have to win. We need to produce lithium here. We need to have lithium processing here. We need to have lithium recycling here. We need to do our own uranium here, right? There's just going to be a lot of momentum to that thinking. And here is the sad thing. You would think in that world where British Petroleum has figured out that they have to completely pivot their company, and I think it's not greenwashing, like I really believe they're doing it, right? They're actually cutting their investment in oil. In that world where you've got companies looking to either sell or close oil refineries, and we had 2 oil refineries already closed in California, the oil industry announced yesterday through its American Petroleum Institute, its chief lobbyist, that is going to fight the deployment of charging stations tooth and nail as one of its primary policies. And I thought, on what planet does that make sense? When actually what they need to be doing is to be pivoting, like some of the companies are, to electricity as a business, and thereby participating in the markets they will lose in oil by providing electricity and charging stations through their own investments, which BP is doing.
Okay, so I want to make sure some of the students in the class ask questions. So I'm going to ask you to unmute yourself in a moment if you have a question, but I want to make one comment on what Amy said, in that there is a tension or a conflict between these industrial policy strategies and the environmental policies. Something I just read just yesterday in Europe, that Volkswagen is paying Chinese electric vehicle car companies for their credits to meet the EU standards. And actually the same thing probably will be happening in the United States. So that'll be an interesting uh, question how that plays out, because these environmental policies are very different. They could be united, but they're not.
Well, and part of the sort of Glasgow next stage global climate negotiations is going to be on the mechanisms for aligning carbon
Yeah.
trading and credits across borders. And indeed, Dan, just for the students, I think they'll find this interesting. The United States, of course, has become a major exporter of natural gas and oil. And the EU is having a methane strategy and they are going to have standards for whatever oil and gas that they're going to continue to use as they transition. And they are talking about having a carbon border adjustment, and they have put together satellite technology so that if some US company says, well, I'm not reporting my methane leakage, so the hell with you, you can either buy my gas or not. The EU is going to say, well, our satellites registered the amount of methane leakage you actually have, and therefore here's the border adjustment that we're going to put on tax, we're going to put on your product if we buy it and bring it into the EU. So you're going to see a lot of diplomacy in this area.
Yep. So I see a question here from Aditya. How about unmuting yourself and asking your question?
Hi, thanks, Dan. Hi, Amy. Thanks so much. Just a quick question, right? I mean, I just wanted to understand, since you're talking about an accelerated energy transition, how would you actually see the need for financing, especially given that a lot of developing countries will be cash flow constrained with the economic impacts? And will this kind of put the debate back on the common but differentiated responsibility framework and require a more concrete commitment from countries to actually put money behind the targets that we're talking about?
Spot on question. So absolutely, you're going to have a lot of countries that have built debt and are going to have even more debt, and they're not going to be in a position to fund the infrastructure that they need for both adaptation and energy transition. And we had an interesting event today where the United States provided actually a facility. I can't remember what the country was, but it was a country that had gotten into debt, taking money from the Belt and Road from China, maybe it was Ecuador, and the United States is going to assist them financially in rescheduling their debt. So we're going to have to see, this is going to be a big topic at Glasgow. The United States is focused on how to play a positive role. I think one of the big challenges that will face the Biden administration is that we're short of funds for the United States' own transition and for our own economy. So that puts even more pressure. And there is a little bit of a room for pessimism in two areas. One is China's Belt and Road. China is holding a lot of the debt of the developing world, and countries will not be able to pay China back. And even China, that was considered such a wealthy player, is having their own distressed debt problems in China with their banks. And their national development banks have funded a lot of these projects, and therefore, they're going to have to write down those loans, all the loans to Venezuela and oil. We're going to have to write down, $50 billion. I do think it's going to be a challenge. And I think the interesting thing is going to be that one of the research that we did at the Climate Policy Lab at Tufts showed that part of the reason why you're still getting a lot of investment in coal in the developing world is not only because in some countries it's a cheaper form of energy, but also because you have entrenched interests in those countries that either in the coal industry or in the national state enterprise for electricity, and therefore they're requesting coal. And I think you're going to see a lot of give and take in the negotiations where the Western countries, to the extent that they're going to refocus on doing the funding maybe it won't be the UN Climate Fund, but some other kind of facility, similar facility, I think you're going to see an insistence on the retirement of the use of those funds and having a plan that does not finance coal. And then last point is there has to be an effort to think about how to structure green bond markets or other kind of financial instruments that allow sovereign wealth funds, large pension organizations, both in the developing world and elsewhere, to put capital into the developing world and into the energy transition in the developing world. There could be, good infrastructure funds that would be attractive, and how you set up the finance, how does government guarantees work for that finance? That's going to be a major feature, I think, going forward, because governments are not going to have the funds.
So I see a question from Junia here. Would you like to unmute and ask it?
Dan, Unia is not a registered student, so she can't unmute herself.
Oh, okay. So why isn't she registered? Okay.
She's already fulfilled the requirement of taking this course.
Okay, just a little commentary. Okay, so she asks, what do you think about the...
Sorry, she can talk.
Can I? Okay, yes.
We hear you.
What do you think about the effect of the vaccine on the mobility, telecommuting, and then how people will eventually perhaps go back to using public transit, share mobility, etc.
So I do think that the vaccine, the oil industry anticipates that the vaccine means that everybody's just going to go back to normal. I guess I don't want to be pessimistic. I'd like to be optimistic and say the vaccine's going to work and we're all going to go back into public transportation, but I think it could be a while. And, one of the scarier things, because I just, looked at the history of why do we stop streetcars in the first place, and how do we wind up with buses and other kinds of inefficient transportation systems. Part of what caused that was that mass transit systems back in the early 1900s went bankrupt, 1920s went bankrupt. So I do think we have this challenge in public transit that the longer things go on, the less revenue they have, and then you get this deteriorating service, and then you get to a problem where it's not viable anymore. So I think that's a policy challenge, and there's some interesting experiments that have been done in Massachusetts and other places where they literally figured out that running public transportation for free and having it put in the state budget or the local municipal budget was more efficient than trying to charge people. So I don't know what the path forward is going to be, but I think the opportunity we have is that people have changed their behavior because they had to. Now everybody's Ubering all over the place, which was, more deleterious than it seemed. So the question is, what can we do by design through policy, whether that's at the local level or beyond, to make the right choices in terms of how we restructure the economy to allow for a more sustainable transportation system going forward. And COVID has given us that opportunity, and the fact that we're going to have a vaccination program that will eventually work means that we need to really double down now on what the policy is going to be for urban sustainability. Are we really going to keep certain roads and sidewalks closed and open for pedestrians. We're going to restrict the number of cars that can come into a city. Now that we understand how unbelievably positive that can be, I think those are going to be questions we're going to have to grapple with in the next year.
Thank you.
Okay, I'm waiting for some others. I have a little question for you, Amy.
Go ahead.
So you talked about, Tesla, all the things Tesla can do to keep expanding its market and spinning off products. What's going to happen with those oil companies? Are they going to just kind of drift off into the horizon and disappear? Are they going to do hydrogen or biofuels or electric vehicles? What's going to happen to the oil companies?
Well, typically in history, like the railroads, in the 1940s did not pivot to airline travel, right? You had a new industry, the airline industry, and it pivoted. In the automobile industry, I think the interesting thing is that you do have companies that are looking at automation and thinking about how they would be in the business of selling automated services and not the actual cars. So for the oil industry, I think it's a challenge, and I think there are different approaches. So you have some companies that are maybe smaller companies that have oil fields in the United States, and they're going to just try to clock down their reserves and sell as much as they can and make the cash flow on it until there's no longer a market. And they're not going to do anything to pivot. That's just their plan, right? For some of the bigger companies, European companies like Total and Eni and BP and Shell, they've already made a commitment that they need to pivot their capital expenditure, some of them more than others. And the question is whether or not the market will continue to give them capital to do that or not. So not to sound too pro-industry, but I do feel like you have people in those companies that are engineers and logistics experts, and they could be actually pretty well positioned to pivot into other fuels. I think hydrogen is the natural because it's can be both a liquid and a gas, and it's transported in pipelines. And indeed, there's a lot of work being done now about blending hydrogen with natural gas and using existing infrastructure while we gear up the volume of hydrogen to justify having a pure hydrogen pipeline. So I do think that there'll be companies that'll pivot, but not all the companies will pivot. And that's why when I showed you the slide, the market is punishing Exxon for its total inability to pivot. The question is, it's not yet rewarding BP for pivoting. And so that, does leave this question mark. Am I better off as investors are deciding to invest in Ørsted and assume that they will eventually figure out that they want to put a hydrogen electrolyzer next to their giant offshore windmill, and therefore they're not going to need a BP or some company like that to do it.
Yeah. Okay. So I see a note from Stanley Price. Do you want to ask a question? Unmute yourself.
Yes. With COVID, people are walking more. How do we maximize the public health benefits of a sustainable transportation system in the future?
Stanley, I think you summed it up. I really do think that, take a city like New York City, where people fought against having congestion taxes. In New York, for example, they're literally taking parking garages and turning them into food establishments for both delivery and takeout. So I think that if cities, like if I were king in the United States, I can't speak to other countries, but if I were, and I know that a lot of this is happening in Europe, but if I was king in the United States, I would say that cities only get federal funding if they come up with a sustainable streets plan. right? So how are you going to limit cars? How are you going to make accessible cities and public areas so that people can walk, that they can do their errands by walking, and that we can stay outside as much as we can and have small businesses by having, policies and design.
So here's a related question, Amy, from your disciple, Rosa. Rosa, do you want to ask it?
Boy, they put me on the spot there, didn't they?
Okay, I'll ask it.
Am I unmuted now? Hi.
Oh, there, you're unmuted. Hi, Rosa.
Hi, Amy. I'm so excited that you're giving this seminar. For those who don't know it, I was postdoc with Amy, and I did my PhD dissertation with Amy too. So super excited that she's here. My question is, due to fears of COVID, we see people trying to move to the suburbs or even more rural areas. How do you think this will affect travel demand and car ownership? And do you think that's going to be like temporary or it's going to stay?
So I don't think it's going to be temporary, but it might be temporary. So some of the people, Valerie Karpus has done some initial work on this, and it has actually raised VMT because, of course, you have to drive a little farther to go to the store. You have to do this, you have to do that. If you were living in, LA or Manhattan or San Francisco, you were probably doing those things by public transit or walking. So it has, I think, increased VMT, but, and that's a big but, car sales are down. And what I would say to you is, as a person who lived in Davis, and many of you who are on the call that remember this, I did have a dual fuel plug-in vehicle when I lived in Davis. And my husband, I shouldn't say this in a public talk, but my husband had a very nice car, let's put it that way. And he never used this very nice car. Whenever one of us was going to do an errand, we both took the plug-in car. We never used it on gasoline, only if we had to go visit relatives in San Francisco. So, one of the things we learned from having a plug-in car in a place like Davis that actually had charging stations, and we had a home charger, was that we only had a 25-mile battery range, and that was good enough. And so I do think that as we transition to technologies, if people become more aware, maybe not in remote rural places, but certainly in the suburbs unbelievably lend themselves to electrification of vehicles because people are in homes and not in the large apartment complexes, and you can charge at home. When we brought that dual fuel car from California to Connecticut, the car was delivered in the month of August, and I did not put gasoline in it again until the month of November. That is how easy it was to use. And there's no charging stations here in Connecticut, at least in my neighborhood. So basically my garage charger, and my husband continued to only use that car, not his other car. So that charger basically meant that we were able to be 100% electrified in all our errands in the suburbs. So I think that the initial push and the initial statistics that we're seeing in academic studies looks highly negative, more VMT, more gasoline cars, more millennials buying cars. But I'm not sure that that's really like the long-term trend.
So just little plugs for those of you that are students or beginning. So Gil Tal's group, the Plug-in Hybrid and Electric Vehicle Center, is doing a lot of work on trying to figure out to what extent people, like with a plug-in hybrid, for instance, like Amy's, how much of the time do they drive on electricity and how much on gasoline? How much do they even use do they use the car more or less than a gasoline car? So there's lots of research at ITS going on that. And Giovanni Circello, who heads up our Three Revolutions research program, is looking at analyzing these questions about the changes in VMT due to COVID, due to ride-sharing companies, and so on. So ITS is kind of actually probably the center of the world on those two research topics.
And they're very important research topics, because if we want to have transportation decarbonize, you have to have the answer to those questions, and you have to fashion policy to push the technologies in those directions.
Yep. Okay, do we have any other questions?
Yeah, we have our next question from the students are putting questions in the chat. So Trisha Ramados, if you want to either unmute yourself and ask your question.
Yeah, thank you. Jaime, that was a really great presentation, very insightful. So I was wondering if we're already beginning to see VC investment shift towards green tech and cleaner solutions, or is it just forecasted for the next few years?
No, you're seeing a lot of money move in that direction. And I think that comes from a wide variety of sources. It's not just venture capital. It's what we call the hedge fund community is pushing their money on those companies. If they're companies that come out with an IPO, or there are companies that are already traded in markets, a lot of big money is being pushed in that direction. In fact, some people are saying so much money is being flooded into those companies, and there's not enough companies with opportunity, and so therefore we're getting a bit of a bubble. And indeed, the way that works is, one of the things that's driving it is that these big fund managers like BlackRock and Fidelity that handle people's money, handle the wealth offices of wealthy individuals, or handle, the investments. I think somebody said they were calling from the United Arab Emirates, people who maybe in the United Arab Emirates, the government has its own sovereign wealth fund. A lot of that money is chasing these clean energy opportunities because they're considered to be growth opportunities. Even if a company is small now, if they have a very good product, people want to be in on the ground floor. So if you're a company making electrolyzer parts today to make clean hydrogen, people are chasing you down. And then you have corporations buying into small startup companies. So for example, there's a very successful Canadian small startup company that had a technology that successfully takes carbon out of the air through a process we call direct air capture. And actually, surprisingly, Chevron and Occidental Petroleum bought shares in that company and invested in expanding their technology as part of their plan for being more net zero going into the future. So you're seeing a lot of money come into that area. I think COVID has only intensified the pace. And indeed, just as investment in oil and gas has collapsed under COVID, the deployment of renewable energy has gone faster, not slower. And like I said, the amount of money chasing those opportunities has gone up.
So we have a question from Sravja. I'm not sure if that's how you pronounce it. Would you like to ask it?
Yeah, that's right. Thank you, Dan. Hi, Amy. My question is related to policy. So I have heard that US has laid the first ever regulations for aircraft emissions. So I was just curious, why did it take so long to regulate aircraft emissions in the United States?
So I think it's not just the United States that it's taken a long time. And it's interesting you asked that, because I was just on a phone call with an industry group, an oil industry group, and they were like, well, we want to know, how do you feel about explaining certain things, about things that are hard to decarbonize versus things that are easy to decarbonize. And fortunately, air travel has been one of the hardest industries to decarbonize. So I mentioned to you data optimization. There's no question. GE and the airline industry has worked together to come up with these big data analysis things, which plane to put on what route, depending on what weather. And they say that those big data logistics programs have reduced the use of jet fuel by 20%. So that's, basically we'd have to do the math, how much that reduction in emissions that is probably not a one-for-one correspondent, but definitely reduces emissions. But we're yet to have a real highly deployable solution for airplane decarbonization. So I've met with a company in the US that claims to have a hydrogen canister solution. So they have developed these safe hydrogen canisters, which they say could be stocked at airports and then put in airplanes. And the airplane could run on a fuel cell. You have parties working on biofuel, diesel, and other basic biojet fuel, because jet fuel is sort of an offshoot of diesel fuel that could be used for planes. So we're just not there yet. And you can regulate emissions, but if there's not a technology for which an airline can comply with that regulation, then you have a problem, because what do? Do you loosen the regulation temporarily? You have this chicken egg problem, and Dan can talk a little bit about that with the low carbon fuel standards. Like, I'm telling you to comply, and when you comply, you'll invest in the technology. But what if you invest in the technology, it's not ready yet? That happened with cellulosic biofuels, where there was a regulation in the United States that a certain percentage of ethanol had to be made from cellulosic, and it just wasn't. It just, the science never got there, and so we have this whole messed up renewable fuel standard that has to be redone, that the Trump people didn't wind up fixing, because it's like the third rail of transportation fuels. It's like anybody who touches it gets electrocuted and their political careers ends. So interesting to see what the Biden team will do about that. It's the same kind of problem. So I think that's been really the holdup in the airline sector.
Good insights. Any other questions we have from anyone? I'm not seeing or hearing any. Oh, okay, here, some are coming in now. Let me.
Looks like Giovanni had a question.
Giovanni's still around, and then two more. Oh, was that you? Okay, I guess that's it. So yeah, Giovanni, did you want to ask something?
Giovanni, I like your question. I see it in the chat. You want to ask it? Oh, you can't. Well, I see it. It's a great question.
You can, Giovanni.
Go ahead, try again.
Okay, can you hear me now?
Yes.
Okay, hi Amy, great to see you.
Hi, how good to see you.
Thank you for a wonderful webinar. My question is about international relations and potential for some tensions with countries like Iran, Venezuela. In the past, these have really affected a lot the oil market. And I wonder, in the future, do you still think is a reason for potential instability in the oil market? Or because we have now more diversification of energy sources with the renewable, but also oil countries. We have a production in the US and in other countries. This probably protects us more from this type of instability in oil prices and everything else this generates, potentially on demand and price equilibrium with other sources.
Well, timing is everything. But let me tell you why. Like, for example, I'm teaching international energy policy this semester, and I'm replacing the oil crisis simulation with a electricity hacking and coercion simulation, because I think that's more relevant today. So, and let me explain why. So, because of COVID, believe it or not, 1 billion barrels of extra oil wound up being built up in storage around the world. That's a hell of a lot of extra oil. And, we're starting to work that down because we had the economic recovery in some places like China and elsewhere. And OPEC cut its production, and US companies cut their production because prices were low. And so the market is what we call rebalancing a little bit. And that's why oil prices stopped going down. But we still have a lot of oil in inventory. And that means that if, suddenly, there was a problem with Venezuela or Iran, inventory can address that in the short term. And that's why people are a little more optimistic. And then, of course, to the extent that oil prices go up, say they went up $10, then we'd see more production in the United States because companies would have more cash flow. So I do think there's this sense in oil itself that the supply would be there if prices start to go up. But that's sort of a short-term phenomenon. What I think has really changed in a sort of a, if I can date myself and say in a sort of 1973, 1979 kind of way, where like some catastrophe took place and we had a giant shortage of oil. Back in 1979, if you were commuting to work by car and suddenly you couldn't get gasoline, you either couldn't go to work or you couldn't go to work, and you would have to call around to everybody to figure out if somebody had gasoline and could they drive you to the train station. I mean, that's literally what it was. You'd have to phone tree to find people, somebody who had an automobile with 6 seats that could take 5 other people to the train. But now, think of all the things you could do with automation that already exists and is completely neutral, right? You could use an app and in some places, in some countries, they've had a temporary disruption in gasoline supplies, and they actually cut a deal with Uber where they gave Uber priority for fuel, and then Uber's drivers would facilitate carpooling to help people get around. But we would use e-commerce, for example. Maybe, the government would give vouchers to Amazon, and you wouldn't even have to go to the store because, Amazon would just bring it to you, and they would have priority for fuel because they're an essential, transportation company. So you could see how in an emergency, it would be easier to fix it than it has in the past. And then, of course, like you mentioned, there's more electrification possibilities. Maybe people would move to an electric car. More people would move to an electric car. And over time, or maybe we would all just have to go back to telecommuting if you weren't in essential services. Maybe you would, cancel trips again, right? So I just think that the demand response could be quite large. And it's not as inflexible as it used to be. And then one of the great lessons that OPEC has learned, and believe me, they've learned it, is that every time they jack the price up, what happens is permanent changes are made, like the ones I'm talking about, where you get in the habit of telecommuting, or you buy an electric car, or you convert your city to a pedestrian center and have people walk, and it doesn't go back. And so as a result, the oil demand is lost permanently. And I think we're going to see that more and more over time. So to the extent that oil prices go back up because there is some kind of international event, expect governments to step in, tax oil, put on, more tailpipe restrictions, put on more restrictions on the use of car, hasten the ICE bans. I mean, all these things could go even faster if we had, I feel like we have one more international oil catastrophe in store for us. Some point when we get past, when the vaccines do work, as we had a great point on that. Say we get to the vaccine side, we don't have another pandemic, people start to forget that they can do all these things. We don't care about climate change again. Hopefully that wouldn't happen, but say it did. Then in that case, if we did have an oil catastrophe again, we have very high prices. I think that'd be the last time, because I think there's so many policy tools and so many technologies that people could shift to that I think they would just accelerate it.
So Amy, we only have a few minutes left, but we got several questions in that I know you love to answer. So see if you can give
Rapid
short,
fire, rapid fire. Go ahead.
rapid fire. Okay, I'll let Shenglun, do you want to ask your question? Okay, I'll ask it because I know you're going to like this one. It says, so if electricity is, do you think, it says it looks like electricity is a dominant energy source, but what about renewable energy like hydrogen or biogas? The biogas is what I knew
love
you wanted.
Right. Well, let
Okay.
me tell you, you know, one of the lessons that people are going to learn when there's a wildfire in California or a ice storm in New England or a flood in China is that when you electrify everything, it means that you have a problem because you don't have access to electricity sometimes because of an unexpected event. And so I do think it would be wise to have additional fuels. And then also, of course, seasonally, as we move more and more to renewables, that is going to make hydrogen a more important energy carrier, especially for, you know, we're going to find it's becoming increasing economical to do deep offshore wind. And hydrogen, generating green hydrogen from those wind farms is a brilliant way to bring that renewable energy as storage for seasonally to balance solar and other things that are not going to be, you know, in Norway, it's only light out like 3 hours a day in the winter. So you have to have something other than solar energy. So hydrogen from wind or from other sources, you know, is a good option. And so, and you can store hydrogen in the summer and use it in the winter. So I do think I'm a kind of a big believer in hydrogen. And when it comes to biogas, of course, we have to address methane leakage and we have to come up with technologies that address methane leakage, which I think we're moving in that direction, EU and United States especially. Maybe we'll put some pressure on China. So the reason I'm interested in biogas is that we have to solve this problem of waste. I mean, waste is a serious societal problem. And taking waste and piling it up on a mound on the ground all around the world or leaving it in the ocean is not a waste solution. So regardless of whether it's inefficient or not inefficient to turn it into energy, you can turn it into energy. And so therefore, to me, that is a better solution than sticking it on the ground. So I'm supportive of biogas, and I do think it's something we should be working on. And to the extent that we need to make it more sustainable because it's methane power to it. And then, you know, as Rosa and I have often advocated, if you're taking an existing landfill, which is already just leaching the methane into the sky, all the more better to use that as a resource in transportation, because at least it's not coming out as pure methane, at least you're burning it.
Well, thank you, but I think we've run out of time. People are still asking questions though. So maybe you can email Amy directly if you want to follow up. And I think her email's been available. If not, Anne-Marie can provide it. So thank you so much, Amy. You've been informative, provocative, insightful, everything we want with our speakers. So thank you so much. And we hope to see a lot more of you in the future, and glad you're still working with us, even at Tufts.
Yes, I look forward to our future work stream of research, and it's a pleasure to meet the students and do today's seminar, and hopefully next time in person, hopefully the Silomar, back in the Silomar, since we're outside, we could maybe do that.
Yep, that's the plan. All right, bye everyone. See you next week.
Thank you.
Thank you.
Thank you.
Thank you.